Hello students. So in the previous video we discussed about inverse transforms, and in that we have two methods: partial fraction expansion and power series expansion. Now we took some examples on partial fraction expansion. So in this video we'll continue further. Now here we have a example given: find the inverse Z transform of x of z is equal to z square minus 3z divided by z square plus 3 by 2z minus 1 with ROC lying between 1 by 2 and 2. Now this is the problem here. In this, if we can observe, the powers are not in negative, so we have positive powers for z. Now this denominator, no matter what, so this should start with 1 as per the general expression for partial fraction expansion. The denominator, because a naught value equals 1 here. Now here we have z square in place of a naught, so that means we have to bring it to the form so that we can apply inverse partial fraction expansion. So we have to bring it to the standard form. So that's why if you look at the expression, the one which is having highest power, so you should divide both the numerator and denominator with that power. So coming to that, if you see this term is z square and we have to make it as 1. Okay, so that's why we have to divide both numerator and denominator by z square. So if you do that, we'll get x of z as, if we take the numerator to be 1 minus 3 z inverse divided by 1 plus 3 by 2 z inverse minus z to the power of minus 2. So both the numerator and denominator should be divided by this term. Now if you take the factors for these two, the denominator, so you'll get 2 and 1 by 2 here. So the expression will be minus 3, 1 minus 3 z inverse divided by 1 plus 2 z inverse and 1 minus 1 by 2 z inverse. Because you can check this, if you take the factors for these two, so this should give 3 by 2 z inverse when added, and when multiplied it should give you z to the power of minus 2. So that's why the factors will be 2 z inverse and 1 by 2 z inverse. So this is just for your reference, I am writing that. So coming to this, if you observe the numerator and denominator, the powers are 1 and here the power is 2. So m is equal to 1 here, n is equal to 2. So therefore m is less than n. So we can apply the partial fraction expansion. So using partial fraction expansion, so we can write x of z is equal to k1 divided by the denominator 1 plus 2 Z inverse plus K2 divided by 1 minus 1 by 2 Z inverse. Okay. Now to find the unknowns, K1 is equal to 1 plus 2Z inverse into x of z, where z takes the value of psi. Here in case it is minus 2, so z takes the value of psi l. Now if you substitute that 1 plus 2 z inverse, the x of z is 1 minus 3 z inverse divided by 1 plus 2 z inverse and 1 minus 1 by 2 z inverse, where z takes the value minus 2 here. These two get cancelled and you will remain with 1 minus 3z inverse divided by 1 minus 1 by 2 z inverse, where z takes the value minus 2. So now if you substitute the value, so this will be 1 minus 3 and it is z inverse. So that means you have to take this value as minus 1 by 2, and in the denominator you have to take this as 1 minus, if you take this 1 by 2 and this is minus 1 by 2, that gives you 1 plus 3 by 2 divided by 1 plus 1 by 4. Okay, if you simplify this, so to LCM you get 2 plus 3 here, in the denominator you'll get 4 here, you'll get 4 plus 1, so that gives you 5 by 2 divided by 5 by 4, 5 get cancelled, 2 ones are 2 twos are, and 2 goes to the numerator. That will give you 2 as the answer for K1. Now for K2, it is 1 minus 1 by 2 z inverse into x of z, where z takes the value of psi l. Here it is just 1 by 2 here. Now substituting this x of z, 1 minus 3z inverse divided by 1 plus 2z inverse into 1 minus 1 by 2 z inverse, where z takes the value 1 by 2. So these two get cancelled. You will remain with 1 minus 3z inverse divided by 1 plus 2z inverse, and z takes the value 1 by 2. Now if you substitute that, 1 minus 3 into, since it is the inverse, you will get 3 into 2 plus 1 plus 2 into 2. So that is 1 minus 6 divided by 1 plus 4 in the denominator. So that minus 5 by plus 5, that will leave you with minus 1. Therefore, x of z is equal to, the first value is 2, k1 value is 2 divided by 1 plus 2z inverse plus minus 1 divided by 1 minus 1 by 2 z inverse. Now, if you take the inverse Z transform, you have to consider the ROC. So, given ROC is equal to ROC lies between 1 by 2 and 2 here. That is, it is greater than the circle 1 by 2, but inside the circle 2 here. So, just for reference, I am writing this. So, this is where the ROC lies. This is circle with 2, and this circle is having radius 1 by 2. So, this is where ROC lies. So, that means the one which is outside the circle ROC, that will be the positive time sequence, and the one which is inside the circle, that will be the negative time sequence. So, that's fine. The first term becomes negative time sequence, the second term is positive time sequence. So, taking inverse Z transform, now if you look at this, both resemblance to alpha n into u of n, that is 1 divided by 1 minus alpha z inverse. Now here in place of alpha we have minus 2, in place of alpha we have 1 by 2. So based on that we can write the final answer as x of n is equal to, so first one is a negative time sequence, so 2 into minus, so there's a negative time sequence, and in place of alpha we have minus 2 to the power of n into u of minus n minus 1 plus the value of k2 is minus 1 into, this is the positive time sequence, and in place of alpha we have 1 by 2, 1 by 2 to the power of n into u of n. Now simplifying that, you'll get minus 2 into minus 2 to the power of n, u of minus n minus 1, and plus into minus minus 1, I'm leaving that, 1 by 2 to the power of n into u of n. So this is the negative time sequence and this is the positive time sequence. So this is our x of n. Moving on to the next one. Here we have a different kind of problem. So that is given by find the inverse Z transform using partial fraction expansion method. So given x of z is equal to 1 plus 2z inverse plus z to the power of minus 2 divided by 1 minus 3 by 2 z inverse plus 1 by 2 z to the power of minus 2 with ROC z greater than 1. Now if you take this, if you observe, both the numerator and denominator are having equal powers, and if you want to apply partial fraction expansion, so the numerator power should be less than denominator. Okay, and before going to that, if you observe the denominator, we have to take the factors for that. Now taking the factors, for that you will get x of z is equal to 1 plus 2z inverse plus z to the power of minus 2 divided by, now the factors for this denominator is minus 1 by 2 z inverse and z inverse. So minus z inverse and minus 1 by 2 z inverse, that means if you multiply you should get 1 by 2 z inverse, and if you add, you will get minus 3 by 2 z inverse. And here m is equal to 1, sorry, not 1, it is 2, and n is also equal to 2. So therefore, m is not less than n. So in this case, we have to perform long division method to bring uh, the x of z into the form so that we can apply partial fraction expansion. So that means we should bring the given x of z where into form where m is less than n. The power of numerator should be less than denominator. So to make that happen, so let's go for long division method. So using long division method. Now here you observe the numerator, you don't need to take this one. So you take the one which is given, consider these two terms, and you have to apply the long division method. While writing this, you have to go with high to low power. So higher order power should be written first. So that means you have to rearrange the expression. That means the numerator is z power minus 2 plus 2z inverse plus 1, because this is the one which is having the highest power, which we have to eliminate. So the divisor should also be written in the same way, highest power to lowest power. So 1 by 2 z to the power of minus 2 minus 3 by 2 z inverse plus 1 here. So main intention is to eliminate the first term in long division method. So we have to select the quotient in such a way that that should be equal to z to the power of minus 2. So if you multiply that, it should give that. If you observe, the first term is 2 z to the power of minus 2 is there, but we have the coefficient 1 by 2. Now to eliminate that 1 by 2, we have to multiply with 2. So 2 and 1 by 2 will get cancelled. You will remain with z to the power of minus 2 only. So that's why z power minus 2 minus 3 by 2, 2 to get cancels, you will remain with 3 z inverse plus 2 into 1 is 2. Now the symbol will alter here. This become plus and this become minus and this become minus as well. So this term is cancelled. Now plus and plus 3z plus 2, we have common uh, powers here. So that means we'll get 5z inverse, and this one is plus and this one is minus, so you'll get minus 1. And if you observe, now the power of this divisor is 2 and this remainder power is 1. So that means we can't go further here. So we have to stop the long division process, and we have to consider two things. This remainder will be our new numerator, and this quotient we have to consider, which is c of x, cx of z, sorry, cx of z. Considering this term, we will get x of z as, I will explain once again here. You have to stop long division when the power of this remainder becomes less than that of the divisor power. Okay. Now the divisor power is 2 and the remainder power is 1. So that's why we are stopping the long division method. If if you get this in one step, you stop there itself. If it takes more than one step, you go further. Okay. Now this has to be written in the proper order. So minus 1 plus 5 z inverse, because we rearranged while performing this long division process. And before considering the remainder, first you have to write the quotient here. So quotient is 2 plus this, then our new numerator is minus 1 plus 5 z inverse in the right order divided by, since we have found the factor, I'll write the factor directly here. 1 by 2 z inverse 1 minus z inverse. these can interchange. You can write 1 first, and after that you can write 1 by 2, whichever finds better for you. Now we have to apply partial fraction for the second term, this term. Okay, so this is not touched here, so we keep this till end. This one we have to apply partial fraction. So applying partial fraction for second term. So you have to mention that clearly. We are applying the partial fraction for second term. So x of z is equal to k1 divided by 1 minus 1 by 2 z inverse plus k2 divided by 1 minus z inverse. Now to find k1, so first we'll write the denominator of that 1 minus 1 by 2 z inverse into x of z. Now when it says x of z, you have to consider this term, the second term, not the entire term. Or to keep that simple, to make the differentiate between these two, you can rename this as x1 of z, just to make that look different. So we determine this as x1 of z. That will avoid the confusion, because x of z means you have to consider entire term, but if it is x1 of z, you have to just take the second term. Okay, or if you want to avoid that, applying partial fraction for second term, after writing this, just below write x1 of z is equal to minus 1 plus 5z inverse divided by 1 minus 1 by 2 z inverse and 1 minus z inverse. So this will avoid the confusion for you. Now we are applying partial fraction for the second term, which we renamed it as x1 of z, which belongs to x of z only. And here also you mention this as x1 of z, where z takes the value of psi l. Here in place of psi we have 1 by 2. So substituting that, 1 minus 1 by 2 z inverse, and x of z is minus 1 plus 5z inverse divided by 1 minus 1 by 2 z inverse 1 minus z inverse, where z takes the value 1 by 2. So these two get cancelled, and you'll remain with minus 1 plus 5 z inverse divided by 1 minus z inverse, where z takes the value 1 by 2. Now substituting the value for z, minus 1 plus 5 into 2, because it is z inverse, and divided by 1 minus 2 here. So that case minus 1 plus 10 divided by minus 1. So you will get 9, and minus is there, the denominator, that makes it as minus 9. So this is k1. The same way for k2, we have 1 minus z inverse into x1 of z, where z takes the value 1. So 1 minus z inverse into minus 1 plus 5z inverse divided by 1 minus 1 by 2 z inverse into 1 minus z inverse. So these two get cancelled. Here z takes the value 1. We will remain with minus 1 plus 5 z inverse divided by 1 minus 1 by 2 z inverse, with z taking the value 1. Now if you substitute that value, minus 1 plus 5 into 1 divided by 1 minus 1 by 2 into 1. So minus 1 plus 5 divided by 1 minus 1 by 2 is 1 by 2. So that will leave you with minus 1 plus 5 is 4 divided by 1 by 2. If 4 goes to 2 goes to numerator, that is 4 into 2, which we will get as 8. Now the value for k2 is 8 and value for k1 is minus 9. So therefore x1 of z is equal to minus 9 divided by 1 minus 1 by 2 z inverse plus 8 divided by 1 minus z inverse. So now if you use this in x of z, so x of z is equal to 2 plus minus 9 divided by 1 minus 1 by 2 z inverse plus 8 divided by 1 minus z inverse. Now this, as in the previous case, it is similar to alpha n into u of n 1 divided by 1 minus alpha z inverse. But looking at the ROC says z is greater than 1, so therefore it is outside the circle of radius 1. So that means x of n is negative, sorry, not negative, it is positive. Positive time sequence or right-sided sequence. So just to have a clarity about this, here we have two circles, one with radius 1 by 2 and another one with radius 1 here. Now the ROC is greater than 1 means it is outside this circle. So this is ROC. So if it is greater than 1, if it is outside the circle of radius 1, then obviously it is outside the circle of 1 by 2 as well. So that means both the terms, first and second, we are right-sided sequence only. Now that part is over. So this is right-sided, this is right-sided or positive time sequence. Now what about this 2? Now if you remember, the Z transform of delta n will give you 1 as a Z transform. So if you go with 2 delta n, then you will get 2 as the Z transform. So based on this, we can write it as 2 into delta n when we apply inverse Z transform. So taking inverse Z transform, so we can write x of n is equal to, so first term is 2 here. So based on this, I can write it as 2 into delta n plus minus 9 is the value of k1. Since both are positive time sequence, it is in the form of alpha n into u of n. So that means we have, in place of alpha, we have 1 by 2 to the power of n into u of n plus 8 is the value of k2. Now in place of alpha, we have 1 here. Okay, so we can write it as 1 to the power of n into u of n. Now simplifying this, you'll get 2 delta n minus 9 1 by 2 to the power of n into u of n plus this 8 1 to the power of n. You can write it as it is, or you can leave that 1 and you can just write 8 into u of n. So that doesn't make any difference. Okay, so this is the inverse Z transform of x of z. So in the same way, let's take one more example here. So same thing, find the inverse Z transform of x of z using partial fraction expansion method, given x of z is equal to z cube plus z square plus 3 by 2 z plus 1 by 2 divided by z cube plus 3 by 2 z square plus 1 by 2 z. Here the ROC is less than 1 by 2. So this one, you can see the powers are in positive, and observe both the numerator and denominator. Uh, you have we have to bring it to the standard form so that we can apply the partial fraction expansion. So that means this term should become 1 here. So again, z cube is the highest power, dividing both numerator and denominator by z cube, we get x of z is equal to 1 plus z inverse plus 3 by 2 z to the power of minus 2 plus 1 by 2 z to the power of minus 3 divided by 1 plus 3 by 2 z inverse plus 1 by 2 z to the power of minus 2. Now in this form, if you look at the powers, so here it is 3 and here it is 2. So that means we have to bring this to the form, because m is equal to 3 here and n is equal to 2. So that means m is not less than 2. Again, the condition is not satisfied to apply partial fraction expansion. So we have to bring it to the form so that we can apply the partial fraction. That is done by using long division method. So using long division method, so again write the numerator and denominator in the reverse order, highest to lowest. 1 by 2 z power minus 3 plus 3 by 2 z power minus 2 plus z inverse plus 1. So this is the numerator. So same is for denominator, 1 by 2 z power minus 2 plus 3 by 2 z inverse plus 1. Okay. So we have same coefficient 1 by 2 and 1 by 2. In place of this, we have z cube here, we have z to the power of minus 2, we have z power minus 3. So that means if you multiply with z to the power of minus 1, the first term will be eliminated. So that gives us 1 by 2 z to the power of minus 3 plus 3 by 2 z to the power of minus 2 plus 1 into z inverse is z inverse. Now this will definitely change the signs here. So this will get cancelled, this will get cancelled, and this will also get cancelled. We'll remain with 1 here. Now if you look this, the power of 1 is less than that of the divisor power. That means we have to stop the long division process here itself. So now we will get x of z as the quotient. First we have to write the quotient z inverse plus new numerator is 1 divided by, let's write the denominator 1 in the right order, 1 plus 3 by 2 z inverse plus z 1 by 2 z, I guess. Yes, 1 by 2 z to the power of minus 2. Now for this we can apply partial fraction expansion. So before going to that, uh, x1 of z, so let's write it like applying partial fraction for the second term. So this is the second term. So let's write it down. x1 of z is equal to 1 divided by 1 plus 3 by 2 z inverse plus 1 by 2 z to the power of minus 2. Now if you take the factors, so you'll get 1 divided by 1 plus 1 by 2 z inverse. We are already taking always 1 by 2 first. In this case, let's make it different. I'll take 1 first here, 1 plus z inverse, and 1 plus 1 by 2 z inverse, because it's in the same way. You can write any one first. Okay. So now we can express using partial fraction expansion as k1 divided by 1 plus z inverse plus k2 divided by 1 plus 1 by 2 z inverse. Since these are the factors, you can write any one first here. Okay. So finding value for k1 is equal to 1 plus z inverse into x1 of z, where z takes the value minus 1. So 1 plus z inverse into 1 divided by 1 plus z inverse into 1 plus 1 by 2 z inverse, where z takes the value minus 1. So these two get cancelled. So we'll remain with 1 divided by 1 plus 1 by 2 z inverse, with z taking minus 1 as the value. If you substitute that, 1 divided by 1 plus 1 by 2 into minus 1. So we leave with 1 divided by 1 minus 1 by 2. So that is 1 divided by 1 by 2 here. So answer is 2. So that is the value for k1. So k2 is 1 plus 1 by 2 z inverse into x1 of z, where z takes the value minus 1 by 2 here. So substituting kx1 of z, 1 by 2 z inverse into 1 divided by 1 plus z inverse 1 plus 1 by 2 z inverse, z takes the value minus 1 by 2. These two get cancelled. 1 plus z inverse, z is equal to minus 1 by 2. Now if you substitute that, so you should get 1 divided by 1 minus 2 here. So that will give you with 1 divided by minus 1. So you will get minus 1 for k2. Now x1 of z is equal to, so k1 value is 2 divided by 1 plus z inverse plus k2l is minus 1 divided by 1 plus 1 by 2 z inverse. So finally writing this x of z is equal to z inverse plus 2 divided by 1 plus z inverse plus minus 1 divided by, you can write minus here directly, but I just want to keep that k2 outside, that's why I'm writing minus here, 1 plus 1 by 2 z inverse. Now we have certain things here to deal with. Now if you observe the first term z inverse, so if you perform z transform for delta n, you will get 1 here, but if you perform z transform for n minus k, you will get z to the power of minus k. In the same way, you get z to the power of minus 1. So that means we have delta n minus 1, so which will give you z to the power of minus 1. So z transform of delta n minus 1 is z to the power of minus 1. And the other one, so these two are very similar to alpha n into u of n, that is 1 divided by 1 minus alpha z inverse. And even if you take the negative of that, that is minus alpha n u of minus n minus 1, you will get the same 1 divided by 1 minus alpha z inverse is the z transform for both of them. Now based on the ROC, whether if it is positive or negative time sequence, it will changes. So that is mentioned in the table that I have given for common Z transform pairs. You can refer that. So now continuing with this, so we have the ROC Z is less than 1 by 2. So that means ROC lies inside the circle of radius 1 by 2. So therefore x of n is negative time sequence. So now based on this, if you observe, we have two circles. This is with radius 1 by 2, another one with radius 1. Now the ROC is inside this circle. So that means if it is inside the circle of 1 by 2, then obviously it is inside the circle of radius 1 as well. So that means both fact or both terms will be left sided. So the x of n, if you take inverse Z transform, it will be a negative time sequence. Okay. So based on that, we can write taking inverse Z transform. If you want to be more precise, we mention that taking inverse Z transform on both sides, because x of z, if you take inverse, it will become x of n. So first I'll write this term z inverse. So whether if it is positive or negative, it will be the same, delta n minus 1 here, and this, since it is a negative term sequence, minus, it is in the form of minus alpha n into u of n minus n minus 1. in place of alpha we have -1 here. Okay, so 2 is the value of k1, and here -1 to the power of n, u of minus n minus 1 plus -1 is the value for not plus, again it is minus because the second term is also negative time sequence. -1 is the value of k2, and the coefficient here in place of alpha we have -1 by 2, -1 by 2 to the power of n, u of minus n minus 1. I'll just show it here. Now in place of alpha we have -1 by 2, so that's why you can have this for your reference. So that's why we have written minus there. Now simplifying that, delta n minus 1, and now you can see -1 to the power of n is there, so it will take the alternate value. So I'll write minus here, -2 into -1 to the power of n, u of minus n minus 1. Minus into minus become plus. You can neglect this 1 here. You can directly write -1 by 2 to the power of n, u of minus n minus 1 here. So this is the inverse Z transform for the given sequence. Okay, so this, I hope you have understood this method. That means when m numerator is not less than the denominator, that is the power, if m is not less than n, we have to go for long division method and bring this to the form so that we can apply the partial fraction. And here we can see m is less than n because the value is 0 and n is 2. So we can apply partial fraction for the second term, but don't forget the quotient here. The important thing is, while performing long division method, you have to be careful. You have to write this in the decreasing order power. That means -2, -1 and 1. Okay, z to the power of 0. Both numerator and denominator should be arranged in this way while performing long division method. So after that, it's the second term, we just rename it as x1 of z, and the remaining steps are similar to the previous problems. You will have to find the unknowns k1 and k2 by applying partial fraction, and then combining all you will get x of z. And looking at the table, you have to remember which form it looks like, and based on that based on the ROC you have to verify whether it is a right sided sequence or left sided sequence. You have to identify that. Okay, not verify, you have to identify that. Next, looking at figuring out whether it is negative time sequence or positive time sequence, you have to select whether it is in this form or it is in this form. And after applying this inverse transform, uh, if there is a need, you go for simplification and you will get the end result. Okay, if you have any queries, do comment or reply to this video. Thank you for your time.